Hello students, this is Miss Dalton and today's lesson is on negative and zero exponents. So first let's look at when you have a zero exponent. So I'm going to give you the rule in just a minute, but I want you to think about something. If you've always understood that 5 divided by 5 is equal to 1. Well, let's see how this applies with exponents. If I write 5 as an exponent, that's going to be 5 to the first power. 5 on the denominator will still be 5 to the first power. Now if we use our laws of exponents for division, it says that we need to subtract the exponent. So we'd have 5 to the 1 minus 1 power. Well, that's the same thing as 5 to the 0. So you can see that anything that is to the 0 power will be equal to 1. That applies for variables, everything. So if I have x to the 0 power, x to the 0 power is the same thing as 1. Okay? So you can either memorize this or you can think back to my example right here. Anything to the 0 power will always equal 1. So if you have 4 to the 0 power, it's 1. If you have m to the 0 power, it's 1. If you have 4xy to the 0 power, now notice that the only thing that is to the 0 power is this y. So the y to the 0 power is 1, but it's still getting multiplied by 4x. So you'd have 4x times 1, which equals 4x. So be careful when you see those exponents. The exponents are just attached to what's right beside it. If this is not in parentheses, then it's just the y. For example, if I had 4xy in parentheses and that was being raised to the 0 power, well then that would equal 1. But this is not what that says, so keep that in mind. Okay, let's look at the next example. It says for any number x where x is not equal to 0, x to the negative a. So when you have a negative exponent, what you're going to do is you're going to flip the base or make that the reciprocal. So the reciprocal is 1 over x, and then you're going to raise it to the positive power. So this negative exponent, that's kind of like a red flag that's telling you to flip the base, make it the reciprocal. And then once you do that, you can change it back to the positive power. So let's look at this example. 3 to the negative 3. Okay, so this negative exponent is telling me that I need to flip my inequality, not my inequality, I'm sorry, your base, 1 over 3. And once I do that, I will raise it to the positive 3 power. Now, going from our quotient property, when you have it raised to a power, each of them will get raised to that power. So you'd have 1 to the 3rd power over 3 to the 3rd power. Well, 1 to the 3rd power is 1 times 1 times 1, which is just 1. 3 to the 3rd power is 3 times 3, which is 9, times another 3, because remember it's 3 times 3 times 3. So that would give you 27. And that would be the final answer. So one way that I remember this is just anytime you have a negative exponent, if it's on the bottom, you're going to flip it up to the top, and if it's on the top, you're going to flip it down to the bottom. So let's look at this example. You have 4 to the negative 3, and I just always circle it and draw an arrow. So that's going to come to the bottom, and then we have times x, and then on the denominator, we have y to the negative 2. That's going to flip and come up to the top. So let's rewrite what we have now. On the top, we have the x. That's going to stay. But now we're going to move this up to the top. And when we move it, it now becomes a positive exponent. So it's y to the 2nd power over. We're going to move the 4 to the negative 3 to the bottom. So when we move it, it is now going to become a positive 3. And then we just want to simplify anything that we can. Well, the variables don't simplify. They're just going to stay xy squared. 4 to the 3rd power, remember that's the same thing as 4 times 4 times 4, which would be 64. And there's that answer. All right. So let's look at the next example. Any negative exponent is going to change places. It's going to move over the divisor. So 5 to the negative 2 is going to move to the bottom. X to the negative 3 is going to move to the bottom. Z to the 0 is just 1, so we're going to cancel that out and make that 1. And then Y to the negative 4, that's going to move up to the top. So both of those numerators with the negative exponents are going to move to the denominator. So it looks like the only thing that I'm going to have on top is the y, and it's y to the 4th power because when I moved it, it became a positive exponent. And then I'm going to move those other two down to the bottom. So 5 to the 2nd power will be on the bottom, and then x to the 3rd power will be on the bottom. And now let's just go ahead and simplify it. On the top we have y to the 4th. On the bottom, 5 squared is 25, and then x to the 3rd. Okay, now I will tell you these tend to be tricky little properties for the exponents. I don't know why, but we always have trouble with the 0 exponents and then the negative exponents. If you'll just memorize these, 0 exponent, anything to the 0 power, most people say that it's 0. But again, I'll show you this in class, but anything to the 0 power is equal to 1. When you have a negative exponent, what you need to memorize is that if it's on the top, then it's going to move to the bottom, and if it's on the bottom, it's going to move up to the top. You can see here that this 3 was really in the top, and so it moved down to the bottom. Okay, and we'll work on this some more in class. Make sure you fill out your WISC and put any questions that you have on the WISC so that we can address them in class.